Okay, so hopefully y'all enjoyed that video. Hopefully you also saw some things within that video that you've seen in real life. Hitting a baseball, throwing a basketball, anything. What goes up must come back down. Launching rockets. All of those are models of parabolic functions. Okay, and parabolic functions or parabolas are the graphs of quadratic equations. So that's what we're going to kind of focus on here in Unit 12. We're going to do Unit 12 as kind of a one big lump of understanding. Now, we're not going to do so much of the math and get nitty gritty in the math with this because we don't have enough time. But I really want you to understand what is a quadratic equation, what is a parabola, what are the different parts of a parabola, and where do I see this in real life? So we've learned to solve linear equations like 2x equals 14, but now we're going to solve quadratic equations. And a quadratic equation is an equation that has a second degree, meaning that the x term is squared. So how can we solve these type of problems? Well, we're going to use things called the zero product property. Now, the zero product property says that if there's a product of two or more factors and their product is zero, then at least one of the factors is equal to zero. Or if you think back into your logic classes, we would say if P times Q equals zero, then P equals zero or Q equals zero. So one of the terms must equal zero. So let's start looking at the different parts of a parabola.
The graph of y equals x squared is, as you know, called a parabola. Okay, and basically what I'm going to do now is just give you some language that goes along with that. The lowest point is called the vertex. Okay, it could also be the highest point if the parabola is facing the other direction. And there is also what's called the axis of symmetry, which is basically an invisible line that goes down the center of the graph. So if you folded it over, it would actually be symmetric about that line. Okay. Depending on your teacher or whatnot, you're going to have to do various levels of precision. Okay. Some teachers just want to see a vertex in the general shape. Other teachers want to see specific points, sometimes 3, sometimes 5. So what you need to do is find a point here and a point here. The cool thing about the axis of symmetry is that if you find a point on the right side of your graph, you can always just transpose it over to the other side. If you're out 2 units and up, say, 2 units, you know that then you're out 2 and up 2. If you're out 3 and up 5, you also know that you're out 3 and up 5 on the other side. So using the axis of symmetry can be really helpful in taking some shortcuts in finding points in order to plot your graph. But basically, the main vocabulary that we're going to talk about right now is your vertex and your axis of symmetry.
Okay, so as we saw in the other previous videos, this is a parabola. Okay, and a parabola can be either U-shaped or it can be upside down U-shaped. When it is U-shaped, as this picture is, it's positive. Okay, so if we have a parabola that looks like this, those are arrows, it is a positive. Okay, if we have a parabola that looks like this, we know it's negative. Now, those arrows at the end of the U mean that it keeps going forever and ever and ever. Just like lines, it doesn't stop. It continues to go. So that's why we add the arrows in both directions. All right, so this is the parabola of the quadratic equation f of x. Remember, f of x is y. It can be rewritten as y. F of x is equal to x squared. So what this says here is, watch the video. We did. Okay, and then drag the star to the vertex of the graph. So let's drag a star to the vertex of the graph. Here we go. Oops. Drag a star to the vertex of the graph right there. There you go. And then label that vertex. Here we are. And then drag the axis of symmetry. Now the axis of symmetry is where we would fold this U so that one side of the U falls directly on top of the other side of the U. And that axis of symmetry in this case would be right there. So some things to know with your quadratic equation is that the U-shaped graph is a parabola. The turning point is the vertex. The axis of symmetry is always x equal to a number, okay? So that means x is the line x equals some number, whichever it is. It's the vertical line through the vertex that splits that parabola. You also have an increasing side of the function and a decreasing side of the function. The increasing side is where the x values are getting larger, and the decreasing side is where the x values are getting smaller. Okay, the function, the x values are going smaller, smaller, smaller until you get to the vertex, and the increasing is what starts the vertex and gets larger, larger, larger. Okay? All right, so let's look at this parabola. First of all, it is a positive parabola. We are going to take the star and put it on the vertex of the graph right down here. Okay, I'm just putting it right below. Let's look at that vertex and let's label it. The vertex of this graph is 2, -3. So I'm going to write that in here, 2, -3. Now, I want to drag the axis of symmetry onto the graph. So here we go. I'm going to bring my axis of symmetry. Remember, the axis of symmetry goes straight through the vertex. It's a vertical line straight up and down where if I folded that parabola, each side would lay on top of each other. Now the axis of symmetry is the line x is equal to 2. Notice that this 2 and this 2, same value. Now let's color over the increasing interval red. Here we are with that increasing interval. The x values are getting larger, and the decreasing interval right here. Oh, I didn't quite go on the line, but that's okay. Right there. The x values, as we travel along that line from the vertex up, the x values are getting smaller. All right, so example number 2. Let's look at this one. Now this is a negative parabolic function. This is a quadratic equation where you're going to see negative x squared. Okay, so this one is turned down. The vertex is still that turning point. So here's the vertex. We'll put our little star up there. Maybe just a little bit more. Okay, we'll put our little star up there. Then we're going to identify that point. That point is -3, 7. Negative, oh, that's not right now. It's hard to see. -3, 7. Now the axis of symmetry would be the vertical line going through the x point. So the axis of symmetry is where x is equal to -3. So that point, that axis of symmetry, oops, I've got those all grouped together. That axis of symmetry there would be right through here. And that's that line where, once again, if we folded it, the increasing interval and the decreasing interval would lay on top of each other. So let's highlight those increasing and decreasing intervals. So my increasing interval is that starts at the vertex where the x values are getting larger, right there. And my decreasing interval is where it starts at the vertex and the x values are getting smaller. Now, if you've noticed, they kind of continue to get larger, but then at a certain point, they kind of continue, like this is kind of getting close to the x-axis. It may eventually cross the x-axis, but it will eventually kind of look like it straightens out into a straight line. It never does, but it will look that way. And you'll talk about that a lot in Algebra 2. So let's look at this one without moving some stars and lines. So let's identify this parabola. First of all, is it positive or negative? It is negative because it's downward facing. Second of all, what is its vertex? Okay, hopefully you said 1, -1. And then what is the axis of symmetry, where x is equal to 1. Good. Now my increasing interval from the vertex as the x's are getting larger is that direction, and my decreasing interval over there. Great. Last but not least, let's look at this one more time. Again, let's just identify it without moving any stars. I think you guys are getting pretty good. The vertex is what? Yep. And the axis of symmetry. Good. Increasing. Very good. And the decreasing. Good. And it's a positive quadratic, positive parabola. So now we've got to do just a little bit of math. Now, all of those spots where the parabola crosses the x-axis, if I kind of try to draw a rough one down here or over here, here's my x and y axis, here's my parabola. Where that parabola crosses the x-axis right there and right there are two things that we call them roots. I hit the button, sorry. So these 2 points are the roots. They're very, 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 very important in mathematics. And these roots are what we find when we use quadratic formulas and quadratic equations. So remember back at the beginning where I told you if P times Q equals 0, then one of those has to equal 0. So within a quadratic and in a parabola, you noticed each time there were 2 points. There are always going to be 2 points. Not always, I take that back. Most of the time, there are going to be 2 points where the parabola crosses the x-axis. How to find those 2 points is that we will set each part equal to 0. So we'll say x minus 5 equals 0 and x plus 2 equals 0. Now each of these will solve for x, so add 5 to both sides and you get x is equal to 5, and you add 2 to both sides and you'll get x is equal to negative 2. What this answer tells you right here is that when this parabola crosses the x-axis, I'll kind of sketch it down here. It means that it will cross the x-axis at negative 2 right there and 5. So the vertex will be somewhere down there and it will look something like that. Not very pretty because it just freehanded it and it did not find the vertex, but that's what we're finding right here. Okay? So if we go ahead and look at this next problem, we notice that this next problem doesn't look like example number 1. I like example number 1. I just set each part equal to 0 and I was done. Well, we've got to factor it first. So let's go ahead and do that. We know how to factor. We already did it. We need to make a little Ma chart. Here we go. We want something that will multiply to give us 12 and add to give us 8. Well, that's 6 times 2. 6 times 2 is 12. 6 plus 2 is 8. So when we factor this, we get x plus 6, x plus 2. Just what we did in a couple sections ago, or a couple chapters ago. All right, so the first part we have x plus 6 equals 0, and then we have x plus 2 equals 0. This leaves us with x is equal to negative 6 and x is equal to negative 2. These are our 2 roots. So if I were to draw a really fast, ugly sketch, this would look something like this, with that point being negative 2 and that point being negative 6. Okay, these are the 2 roots of the equations. And we are going to be solving quadratic equations to find those roots. Okay, that's what we are going to focus on right now. When you get into Algebra 2, you will definitely be finding the vertex as well and all the fun different parts of it, but we just don't have enough time, friends. We should have, and I will apologize to you and I will apologize to Miss Warneth, but we just didn't get there. Okay, you also have a worksheet within your Google Classroom, and you are just going to be doing problems 1 through 10 on that worksheet. The answers are also on there so you can check and see if you did it correct. Remember, factor first, then set each factored part equal to 0.